Good morning. So now we are continuing the lecture of Gantry Girder. So to understand this part very clearly, I already mentioned in first video also, you have to refer these two videos which are in steel structure playlist, video number 32, where you have theory of Gantry Girder, and 33 where we have problem on this Gantry Girder. Now we have this problem, we are continuing with this. So yesterday we are with bending moment due to vertical loads. Now we have horizontal reaction, and that is equal to horizontal reaction equal to 10% of weight of crab, we have that as 50, and crane capacity which is 180. And this load will be shared by 4 wheels, 2 on left rail and 2 on right rail. So you can see we have crane capacity, you can see over here 180, and then we have weight of crab 50, 10% of it carried by 4 wheels and multiplied by 1.5. That will gives us a reaction on each wheel. And we have this reaction due to horizontal thrust. And now we are interested with bending moment. Bending moment due to horizontal reaction. Due to horizontal reaction. And this will be relate with your reaction. And now we have a horizontal reaction 0.1 into 230 upon 4 into 1.5. You can calculate this. And we have to be in proportion to the bending moment due to vertical loads. We have bending moment due to vertical load is 436.35, and reaction we have 268.68. And likewise, we are going to find out bending moment due to horizontal reaction, and this value comes 14 kilonewton meter. Now then we have step 3. Step 3, yes, selection of section. Step 3, selection of section. Selection of section. Now we are going to select ISWB 500 at 333.31 kg per meter, and we have properties of this. Now actually in one video I mentioned this upon 12 to 15, but here we have span less and load is more. So if you have bending moment about 300, then you can prefer ISWB 400. If it is a range of 400, above 400, then you have to go for ISWB 500. If it is above 500, then you have to go for ISWB 550 or 600. Likewise, we have to go for it. So we have properties A 12122 mm square, 12122 mm square. Then we have TF 14.7. TF is equal to 14.7 millimeter. TW 9.9 millimeter. BF 250 millimeters. And then IYY 2987. 2987.8 into 10 raised to 4 millimeter to the power 4. So these are the properties of ISWB 500. Now you can see BF 250 means we do not have any other choice. We have to go for 300. So we will load is greater one. So I prefer ISMC. You can go ISLC also. So your value is reduced a little. But I prefer because of larger load as MC 351.2 kg per meter. Then we have properties. In the examination, it is always on better side. You can go higher side. So you need not require to revise this section, but do not go much higher side. So A is 4564 mm square. TF 13.6 millimeters. TW 7.6 millimeters. IZZ 6362.6 into 10 raised to 4 millimeter to the power 4. Then we have step 4, design bending stress. Design bending stress. And we know it depends on FCRB, and FCRB value actually depends on KL upon RY and HF upon TF. Now we have total area of section AT is equal to A of beam plus area of channel. Area of beam we have 120, plus area of channel we have 4564. And we have this value 16686 millimeter square. Now I have y total. So here we have IY of beam plus IZ of channel. Now why we are considering this, just I will tell in 1 minute. So we have channel like this and we have beam in this. And then our beam this YY axis. And whereas for channel, we have this as ZZ axis. Go to steel table, there they have mentioned over here. It may be XX or ZZ, they have mentioned over there. And then we have this value. Y of beam we have 2987.8 into 10 raised to 4 plus IZ of channel 6362.6 into 10 raised to 4. It comes 9350.4 into 10 raised to 4 millimeter to the power 4. Now knowing this value, we can find value of RYY, and RYY that is equal to root of IYY upon A total. And then we have IYY that is equal to 9350.4. So we have 9350.4 into 10 raised to 4 divided by total area 16686. And we will get this value 74.86 millimeters. Now knowing RYY, we can find KL upon RYY, and that is equal to 5000 divided by 74.86. And we will get this value 66.79. Similarly, we can find value of HF. So HF we have center to center distance between flange. Then we have total value that will be equal to H of beam plus thickness of channel web. So this will be total depth. and minus, we have to subtract half mm, thickness of flange on one side and half on other side. On one side, we have TF of beam plus TW of channel upon 2. We have considered half of this plus other side we have only beam, so upon 2. And then we will substitute values. We have depth of beam 500, thickness we have 7.6, and minus we have 14.7 plus 7.6 upon 2 plus 14.7 upon 2, and we have this value 489.1 millimeter. Little bit change, it's okay. And then we have HF upon TF, and that is equal to 489.1, and we have thickness of flange 14.7. Now you can say that we have to add all and then take average of 2. So will not change a lot in this value, and we will have this value equal to 33.27. And knowing this value, you can use formula that is of FCRB. Check this formula. I don't remember exactly, but we have likewise. So KL upon RYY whole square in bracket 1 plus, we have 1 upon 20 in bracket KL upon RY divided by HF upon TF whole square to the power 0.5. You can calculate by using this formula, or we can go for table. So we are using now table 14, and from this we are going to find out FCRB. So we have this as 60, we have 70, and then HF upon TF, we have 30, and then we have 35. And then I will directly write values. I will not calculate it because it will be again time consuming. So you can now calculate. You are now well known for this. So we have this as 500, and this is 485.5. And I have calculated this value for 33.27, and we have this value 651.22 and 490.52. And then for 66.79, we have this value that is 554.78. And from this, we will get value of FCRB equal to 542.78 Newton per mm. Now, knowing this value of FCRB, we are in position to find value of FBD. And for this, we have to use table 14A. 13A. 13B is for welded section. We have road section, and we have FCRB and FBD. FCRB we have 600 and then 500. For 600, value is 197.7, and for 500, 186.6. And we are interested to find value for 542.78. And we will get this value 193.81. So we have FBD 193.81 Newton per mm square. Now, if you will go by FCRB, then that FCRB formula, that value is something 533, and FBD, that value comes 194, something like this. That also I have calculated, but not mentioned in the video. Otherwise, the student may confuse for this. So now we are in second video, that is value of FBD. Now in third video, we will go with value of MD, and that will complete our problem. So now we will stop here only. So remaining part we will see in next video. So thank you.